In this presentation, we're going to look at the normal distribution. So this is a worked example. The mass of Arab horses is normally distributed with a mean of 900 pounds and a standard deviation of 50 pounds. Now, just sort of, let's get ourselves started here. So let's first off pick a font or pen size. So this is the mu here is 900. That's to say mu, and that's the mean of 900. And sigma is the standard deviation, so it's this symbol here, something like that, and that is 50. Okay, now just watch out for something. You might actually, first off, x is mass of Arab horses, so we're actually going to use that capital X there to denote mass of Arab horses, so that's capital X. Okay, now something to watch out for is that you might sometimes be given in the question something like this. X is normally distributed with a mean of 900 and a variance of 2500. Okay, that is sigma squared, the variance. Okay, so mu as before, but sigma squared is the variance. So if you get the variance, watch out for that. You might be required to use in this case you use the standard deviation sigma. So you just get the square root of 2500 to get 50. Okay, so calculate the probability that an Arab horse weighs more than 940 pounds. So how we might write that mathematically. So is calculate the probability that an Arab horse, the mass of an Arab horse, weighs more than 940 pounds. So we're also going to do an extra question here. Calculate the probability that an Arab horse weighs more than 945 pounds, and calculate the probability that an Arab horse weighs more than 960 pounds. So we're going to actually ask three questions just to sort of shake things up a bit or put you under more pressure. So 1, 2, 3. What we do here is we calculate the Z score or the standardized value, and that is the Z score corresponding to these are lowercase letters X and Z, but I'm putting a little O beside them just to sort of say it's observed values. Essentially, just like that's not a capital letter, that's a lowercase letter. Okay, so for each case, what we're going to do is get the Z score. So for each of these values, 940, 945, and 960, we subtract the mean and divide by the standard deviation. Now I'm going to do it for the first one only, 940 minus, so that's x0 is 940. Now mu and sigma as before, 900, okay, and divide that by the standard deviation. And the answer is, bit of calculator work, 0.80. I'm going to put this to 2 decimal places for a reason that will become clear shortly. 0.80 is the Z score for 940, 0.80. I'll just write them over here. Now if you do something similar to the other ones, you have 0.90 and 1.20, and again we're putting it to 2 decimal places. Okay, so far so good. Now what does that mean? Well, essentially what we have is we're going to use the statistical tables. Now I'm going to use one called the Murdoch-Barnes, okay, and in particular it is table 3, okay, and this relates to the standard normal distribution, okay, also known as the capital Z distribution or Z distribution, okay, and what this does is tabulates probability of Z being greater than or equal to some observed Z score, okay. So that's what it does. We'll have a quick look at it shortly, but what does that mean for us? So for a probability capital X being more than some particular value is equal to the probability of Z being greater than Z0 if that is the Z score of X. Okay, so for what our example, the probability of x being greater than 940 is equal to the probability of z being greater than 0.80. Okay, so we're also going to do it for 945 and 960. So essentially what I'm going to do is draw a sort of quick sketch of the tables. So we would have the Z scores, Z's down along the column on the rows here, and what we would have is the first two decimal places. Okay, so 0.00 would be somewhere like here. The next row would be next column would be 0.01. The next column again would be 0.02, and so on. Okay. Now let's just say for essentially what happens here is that along the rows you get your values to one decimal place, and to get a further decimal place you would have to just move in according to the rows. So this would be, let's say, 0.7, 0.8, 0.9. Here we have 0.00, and so on. Now, what are we looking for? Just a new page here. So we are 0.80. That is 0.8 plus 0.00. Okay, so that's the row, and this is the column. Okay. Now let's just say, for argument's sake, it was 0.85. The row we would be looking at is 0.8. That'd be the row, and the column would be 0.05. That would be the column. Okay. So, let's get out our values here. And so what happens here now is I have to go. Let's go back up here a second. So I'm just going to sort of put in some values here. So I'm just going to populate this table shortly. I'm just going to pause it here. So there we have it there. Now, the probability, so the first question we're looking for is, what are we looking for here? The z-score is 0.80, okay. So 0.8, and we go to column 0.00. So the p-value here, or the value we're looking for there is 0.2119. Okay. For the other question, the z-score was 0.9, so the the probability we're looking for is the one just below it. I get mixed up with p-values because this is something very similar. It's for another video. Anyway, so those two values there, and also for 1.2, just down below, you would get 0.1151, just a couple of rows below. So what does that mean? Let's go here. The probability of x being greater than 940 is equal to the probability of z being greater than 0.8, and that is equal to 0.2119. Likewise, the probability of x being greater than 945 is equal to, that's a bracket, is equal to the probability of z being greater than 0.9, and that is equal to 0.1841. Probability of x being greater than 960 is equal to the probability of z being greater than 1.2, and that was 0.1151. Okay, so that is the first part done of this worked example. It's 9 minutes in, so I'm going to sort of pause it now and look at the second question. Let's go back to the second question here shortly. Calculate the probability that an Arab horse weighs more than 880 between 880 kilos and 960 kilos. So what we're going to do there is I'm going to do a few variations of three important rules. So this is normal distribution worked example 1 part 1 over.